Now, if you haven't done this before, it is actually really easy. So the next thing we're going to be considering is the double angle formula for trig. And that's actually much easier than you think, because that really means we're just trying to work out what sine of 2 theta is, for example.
You mean this one?
Yeah, and as you can probably tell, you can just use the formulas that we've talked about before and use the addition. So that means sine of 2 theta will be sine of theta plus theta. And then, of course, you just apply it very simply. So that would be sine theta cos theta plus cos theta sine theta, which just means it's 2 sine theta plus theta. Make sense?
Yes.
And cos 2 theta, very similarly, you would just apply the rule we had before, applying theta plus theta, and that would be cos squared theta minus sine squared theta. And I think I'm happy with that, right? Is there any other version of cos 2 theta that I should be aware of?
Like kind of square, like sin squared theta or cosine squared theta.
So, what other versions are there? You've got cos squared minus sine squared. Are there any other versions?
You mean 1 minus 2 sine squared theta?
Yeah, so remember that sine squared theta plus cos squared theta equals 1. So we can use this at any point in time to express sine squared in terms of cos squared. And we can also use this at any point in time to express cos squared in terms of sine squared.
Yes.
And so when we have this here, we kind of have the option to change the cos squared into sine squared. So that means we can then write it as equals 1 minus sine squared theta minus sine squared theta, giving us 1 minus 2 sine squared theta. We also have the option to change the sine squared into 1 minus cos squared to give us cos squared theta minus 1 minus cos squared theta. Note that the cos squared theta minus 1 plus cos squared theta, you're minusing a negative cos squared theta, giving you 2 cos squared theta minus 1.
Yeah.
And then, of course, your tan 2 theta, again, you would treat as tan theta plus theta. You would use our formula on the earlier page and sub in theta twice. And that will very easily and quickly give you 2 tan theta over 1 minus tan squared theta.
Yes.
This then gives us our results that you should know very well. Make sure that you know all 3 versions for cos squared. The sine squared and cos squared versions are actually often a lot better and a lot more important and are used a lot more, just because they only involve one sort of trig identity.
Yep.
In fact, they are quite useful in the sense that if I want to express sine squared theta, now you know sine squared theta equals 1 minus cos squared theta. That's one thing that you've used before, yes?
Yes.
But is there another identity that you can express sine squared theta as? Do you know?
You mean convert into cosine theta or something?
So it's convert into a cosine, but without a square. I'll say without a square.
Oh, I don't know this one.
Right. And so this is where what I'm saying comes in useful as an example. So we know that cos 2 theta equals 1 minus 2 sine squared theta, right?
Yeah.
So just make sine squared the subject. What would that be?
Sorry, you mean the subject?
Make sine squared the subject.
So it's minus cosine 2 theta.
So sine squared theta would equal
1 minus cosine 2 theta over 2.
And that is also something that will be sort of useful. So if you already know the double angle formulas, then that's good. But just like how with the trig identities, where just knowing sine squared plus cos squared equals 1 is not enough, but you also need to know sine squared is 1 minus cos squared equals, 1 minus sine squared, and 1 equals sine squared plus cos squared, then you also need to start recognizing all the other variations. So if cos 2 theta equals 1 minus 2 sine squared theta, you will also use, at some later point in time, sine squared equals half 1 minus cos 2 theta.
Yep.
Similarly, there's an equivalent one for cosine as well. So you can quite clearly see that 2 cos squared theta will be cos 2 theta plus 1, and therefore cos squared theta will equal half cos 2 theta plus 1.
Yes. Yes, that makes sense.
Great. And so we've basically covered everything with regards to further trig. The only thing perhaps might be left is what's called the T formula, which I think is not that useful in my opinion, but it is something that potentially can be tested. So that's something that we might need to go through, but otherwise, we've basically pretty much finished off further trig.